Hey everyone, welcome back, and today let's solve Leetcode problem 3461 titled Check if digits are equal in string after operations part 1. So we're given a string S consisting of digits, and we have to perform the following operation repeatedly until the string has exactly 2 digits. We're going to guarantee that after all the operations, our string is going to end up with exactly 2 digits each and every single time, regardless of the test case, right? So for each pair of consecutive digits in the input string S, we have to start from the first digit and calculate a new digit as the sum of the 2 digits modulo by 10. And we have to then replace S with the sequence of newly calculated digits, maintaining the order in which they are computed, and return true if the final 2 digits in the input string S are the same after all the operations are applied, or we simply return false if they're not the same. And to kind of see this in actual kind of actions here and not actual visual representations. Let's go ahead and look at the example here just to kind of fully understand it. Effectively, in this example, we start with 3902, and in our first operation, we'd get 3 plus 9 modded by 10, so that's going to be 12 modded by 10, which is 2, and again, keep in mind, modded is simply just the remainder method, or the remainder function, so when we're doing something modded by 10, that's basically just the remainder when we divide it by 10. In this case, 12 divided by 10's remainder would be 2, because 10 times 1 is 10, and 12 minus 10 is 2. Applying the same logic to s at 0 plus s at 1 in the first operation, that's 9 plus 0, that's going to give us a remainder of 9, 0 plus 2 is going to give us a remainder of 2, right? And that gives us a resulting string of 2 plus 9 plus 2. Our input string S is now 3. It isn't 2, but it's 3. And since it's not 2, we're going to do one more operation. And so we get 2 plus 9, that's 11. 11 modded by 10 is 1. And 9 plus 2 is 11. 11 modded by 2 is 1. 11 modded by 10 is 1. So we get 1, 1. We do have a string of length 2 now, and 1 and 1 are both equal, and so we do have an output of true. Applying the same logic to example 2, once we get to a final resulting string of length 2, that's going to be 48. Since 4 is not equal to 8, the output is false, right? Because these digits are different. So for the constraints here, we see that the length of our input string S is always going to be between 3 and 100, rather small, and it's only going to consist of only digits, kind of just confirming what the problem statement said and validating that we're always going to have kind of valid inputs, which brings us to the main kind of observations to make to be able to solve this problem. And in this case, it really just is that this is one of those more easy kind of problems on Leetcode, as you see by the label, and usually such problems are just kind of direct simulation / application problems. Usually the problem usually kind of just tells you what to do, and you just have to kind of convert it to code, and this problem is no different, right? It tells you exactly what the procedure is, exactly how the operation works. We're really just simulating this using a while loop while the length of the input string S is greater than 2, and while it is, we're going to just perform the operation by iterating through it and just return if the 2 digits are equal, in a very direct kind of simulation style, right? So nothing too crazy. So let's go ahead and do that. Now I'm going to be using something called list comprehension here in Python. You don't need to be doing that. I'm going to be converting this to an array because it's just really easy. It's a lot easier to work with and modify arrays from consecutive elements than it is with strings. And so that's usually kind of a good practice to use for programming skills and Leetcode problems and data structure and algorithms problems in general. So I'm going to get an array, basically just the array conversion of my input string S, and it's basically just going to be, you guessed it, list comprehension. We're simply iterating through every character in the input string S and converting it to an integer. And so now, instead of it being a string of kind of characters, now it's an array of integers. Of course, the digits themselves in the initial input string S are the exact same, but instead of having the string 3902, we're now going to have an integer with the integer. We're now going to have a list or array with the integers 3, 9, 0, 2, just so they're easier to work with, iterate over, and modify. Right? Now our main condition. While the length of our array is at least 2, or rather greater than 2, we can still perform operations on it. In fact, we still have to perform operations on it until we reach 2. And so while it's still greater than 2, that's kind of our validating while loop. So what that tells us we still have to keep performing operations on our input string S. Right, or rather, in this case, now on our array S. And what I'm going to do now is actually calculate my next array, right, for this specific iteration by basically just decreasing the length by 1, as we saw in the first example. And it's going to basically just be the operation being applied on this input array, right? And basically, again, still list comprehension here, it's going to be at array at index I, you guessed it, at array at index I plus 1, basically just the for current and next elements modded by 10. But you may be wondering, well, we don't know what array at index I is, or rather, more specifically, we don't know what index I is, and that's where, again, list comprehension comes into play. It's going to be array at index I plus 1, basically just the two consecutive elements at index I and index I plus 1 divided by 10 for every I in the range of the length of the input array num. Now keep in mind, we're accessing array at I plus 1. And so to avoid a list out of bounds error here, or an index out of bounds, we have to only go up until the second to last element. So that's length of array minus 1. Right? That's a very important kind of feature to keep track of. We can't go up until the very last element because the very last element would not have a next element. And so we'd have to go up until the second to last element to avoid that kind of a list out of error or list index out of bounds issue. Once we do that, once we update next to that kind of like be our updating array after we apply the operation, we have to update our current array to now be this next array after we actually apply the operation on array. And we then use this array as our next array for future iterations. And effectively, once we exit this while loop here, while the length of our array is no longer 2, that's when we can simply return if the array at index 0 is equal to the array at index 1, and this simply just would output a Boolean value. So when this I made in the syntax 0, 0, this should be accepted, and this should be a valid solution. So let's go ahead and verify that. And as you can see, this really is just about as efficient as you can get it to be. So on a high level, again, how are we really solving this problem? Effectively, again, we're simply just converting our string into an actual array of integers. Then while the length of our array is still 2, meaning while we still have to perform operations until we actually have only 2 elements left, we're simply just going to iterate through the array. And I'm just doing this using list comprehension to do it all in one line. You can do this in 2 separate lines if you want. Doesn't really matter, but effectively we're just iterating through the array of integers, of course, and then summing every consecutive pair of elements, modding it by 10, and setting that or updating that to be our next array, or our new array after we apply that operation, updating our array, and finally returning once we exit the while loop if the 2 digits in our resulting array are equal or not. Right? So for the runtime complexity of this solution here, it's actually going to be big O of n squared. The reason why is because while we are actually using this array to initialize our array from the input string s, that's going to be big O of n. However, since we are actually doing this kind of while loop here within this extra while loop here, this is actually going to be a big O of n squared time complexity. Because keep in mind, we're iterating through every element in the length of our array minus 1, which is just roughly big O of n, and we're simply also updating that into a next array, right, or into another array. And so that's going to be our overall runtime complexity of big O of n squared, right? And of course, that's going to be in the worst case. Now, usually, like specifically for this problem, because n is less than 100 for the problem constraints here, it's going to be perfectly fine. N squared is completely normal. It really doesn't matter because 100 squared is far less than the number of operations a computer can actually perform in 1 second, right? And for the memory or space complexity, it's actually going to be big O of n. In other words, it's going to be linear. And the reason why is because you guessed it, we quite literally use an extra array to store all the elements in the input string s. And although we are updating them in each iteration, they're simply getting smaller from n. That's not really going to hurt our memory complexity. And so it is just linear for our memory complexity, right? So n squared or quadratic for our runtime complexity, for the initializing of this array, and this list comprehension here, and updating our next as well, all in the same loop here. And our memory complexity is simply linear because of this singular extra data structure that scales proportionally with the length or size of our input string s. Right, so if you guys enjoyed the solution and learned something new, please consider liking this video and subscribing to my channel. And without further ado, I will see you guys in the next video. Bye-bye.